Hey, did you do the homework? Isn't it for next week? No, you have only 1 hour left. If you don't submit, you will get F. Ha! I did it. Let's submit it. Professor, I want to ask you about homework. If I had quantum computer, I would have submitted in time. So I want you to
Stop. Hey, I think you don't know about quantum computer. You're totally wrong, so I can't accept your requirement. You're F. Before we talk about Gono's misconception and truths about quantum computer, we should know that what is quantum computers.
Let's start with definition of quantum computer. This is the definition. It is not easy for you because these three concepts, superposition, entanglement, qubit, are not familiar with you. But you have to know it. Then, let's start. The first is superposition. It is due to wave property of quantum state. Similar with sound or light, quantum state can be added together. So, let's think about spinning example. If we have an electron spinning like this, is it up or down? We can express it like 50% up plus 15% down. Next is entanglement. It is due to the conservation of angular moment. You can think two quantum material is connected. Thus, if we know about one side information, we know the other side automatically. For spinning example, if one is upper spin, then entangled the other spin is down. A quantum bit is the basic unit of quantum information. It means the quantum version of classical bit, 0 or 1. A quantum bit can exist in superposition, probability. Let's see example in blow sphere. The red one is up, meaning 0. The blue one is down, meaning 1. Then, the purple one, psi. Is it 1, 0, up, down? It is both. So, we should use superposition. Is it clear? If it is not clear for you, let's toss the coin. Classical bit, the result should be head or tail. But for qubit, it can be have like this. Is it head, tail? We call both. So we should use probability. Now, understand it? But it's time to add entanglement. Let's assume two coins are entangled in opposite direction. Then toss it. We don't know the result. But if we know one is head, the other one should be tailed. Then what is quantum computer again? Comparing classical computer and quantum computer will help you to imagine. Classical computer is based on classical physics, and quantum is based on quantum physics. The electric circuit in classical computer can express only one state, but quantum phenomenon, which is for quantum computer, can express more than one state. And information storage is different. Voltage is used for classical computer, which low is 0, high is 1. But for quantum computer, we use probability, as mentioned in previous slide. The up is 0, down is 1. But superposition, it means 0, 1, both.
So, do you guys know how quantum computer became famous? Before we get to this question, let's talk about this problem. There is a circuit that takes in two inputs, which is X and Y, and spits out two outputs. In this problem, the upper direction is 0 and down direction is 1. Input X always passes right through the circuit unaffected. We don't know what this circuit does to input Y, but there are only 4 possible cases. Case A, it does absolutely nothing to it. Case B, it flips it. These two cases are called laid back, since it is independent of X. Case C, it flips like before, but only if X is on 1. Case D, it flips it only if x is 0. These two cases are called needy, since it is dependent of x. So, with that in mind, here's the circuit. Can you figure out if it is a laid-back case or needy case? You can only see the outcomes, not what is happening in the circuit, and you can use circuit just once. So, when we use classical computer to solve this problem, result is shown like this. We cannot solve this problem since we cannot distinguish laid-back case and needy case. So, classical computer need at least 2 chances to solve this problem. But by using Deutsch algorithm and quantum computer, we can solve this problem. H. Handler gate map the base state 0 to 1 over root and 1 over root 2, and map 1 to 1 over root 2 and minus 1 over root 2. By using Deutsch algorithm, we can get each case outcome like this. Then, we can distinguish the laid-back case and needy case. Problem solved. After Deutsch approach, other quantum computer algorithms are discovered that their first operation and usability makes quantum computer becomes a very popular and topical topic. Schur algorithm is the quantum computer algorithm for integer factorization. Informally, it solves the problem like given an integer n and finds its prime factor. Grover algorithm is a quantum algorithm that finds with high probability of unique input of a black box function that produces a particular output value, using just O of root n evaluation of the function, when n is the size of the function domain.
Finally, let's talk about misconception and truth. First, misconception is statement that quantum computer is always fast. This is partially true, like Deutsch algorithm and Schur-Grover. Quantum computer is fast at approximation simulations such as traffic jam. However, since quantum computing is related to metrics, it is slow if target function is not one-to-one and don't have inverse metrics. Let's see second misconception. This misconception is part right and part wrong. As we mentioned earlier in misconception 1, quantum computer can play a big role in solving non-deterministic problems, but there are some cases which is better to use classical computers. At the present level, even if quantum computers have commercialized, they are used only for simple mathematical calculations, not for games and Windows. And replacing other functions of classical computer with quantum computer shows very low efficiency, such as virtual machine. So development goal in these days is not complete replacement. It is highly likely that there will be era in which quantum computer and classical computer will complement each other in the future. Third misconception is quantum computer has been developed to perfection. Consider that the current code of quantum computer such as D-Wave. D-Wave is commercially available quantum computer that D-Wave system made. But we call D-Wave as a half quantum computer. It is because D-Wave has structure that classical computer receive and use the result calculate in quantum CPU. It's like having a quantum CPU on classical computer. So where the quantum computer such as D-Wave use? NASA and Google use D-Wave for research quantum annealing method and co-established Quantum Artificial Intelligence Lab. Quantum Artificial Intelligence Lab research quantum simulation, quantum neural network, quantum assist optimization, quantum methodology, and superconducting qubit processor. In case of IBM, one of the leading companies of quantum computer technology, announced IBM Q System 1, which is the world's first quantum computing system with a 20-qubit system for commercialization. In addition, they unveiled IBM Quantum Experience for assessing programming and perform various tests by contacting 5-qubit quantum processor in the cloud. Now it can be freely used to program and do various tests about quantum processor. They are developed KAIST, an open source framework for quantum computing. And let's see quantum computers' limitations like this. First, quantum computer state is unstable. Quantum computer can only function if the coherence of qubits ensure that quantum information remains intact. The researchers have now discovered that covalent spontaneous disappear over the course of time, which store information as well. Second is managing sensitive processor and maintaining superconductivity is very expensive and take a lot of space. This is end of our video, and I hope GONU will never make mistake like this.